This is the first multi-piece test cut on the Scrollsaw. If you're not familiar with this project so far, I'm trying to cut jigsaw puzzles with a CNC Scrollsaw. And so in order to cut multiple pieces, I have to keep track of which pieces are cuttable without removing other pieces. So here there are 3 pieces it can cut without any of the other pieces being removed, even though that one just fell out. And so once it finishes a group of cuts, it retracts, and then I can pause the machine, remove the pieces by lowering this table. You see that one piece had fallen down, so I can now get that. And then after it unretracts, I can raise the table again, and it will keep cutting. I'm experimenting with different ways to add more downward pressure, and so here I'm just laying on a metal bar. And it's about to finish its cut, but actually the cut is not totally finished, so when it tries to move to its next starting location, it just snaps the blade. So cut 4, move to start. Oh. I broke the blade. And the reason I think this happened is that the U-axis, which is the rotational axis of the blade, its 0 point was not in line with the Y-axis of the workpiece. So as you move the workpiece forward, instead of being aligned like it should be, it's actually off, which causes an X error. And this error is roughly linear for small angles, but over 300 millimeters, which is about a foot, you end up with about a 5 millimeter X error, which is significant. I think anything over a millimeter is going to be a problem. My goal is to calibrate the 0 point of the U-axis to be within 0.1 degree. My first idea was to sweep a dial test indicator to find the 0 angle at the maximum displacement. But in this setup, I can't easily read the dial to get an accurate reading. And as you see here, I'm kneeling on the board that this is mounted, and I'm already getting a 10th out deflection. So I don't think my setup is nearly rigid enough. And furthermore, you need a very high resolution reading to be able to distinguish down into the 10th of a degree. So even a 1 micron difference corresponds to a 0.4 jump from a 10th of a degree to 5/10. So my next idea is to mount a laser on the rotary axis and then move a target in the X and Y and record those coordinates for 4 different points. And so here I'm taking another angle, and then I'll probe that angle at 2 points on the other side. And then all I need to do is intersect those lines to get the actual position of the pivot, along with I can calibrate the 0 point and calibrate the steps per degree, which was off by about 4% from the theoretical. And I had the program output some hypothetical measurement errors where if all of my X and Y coordinates were within a 1 millimeter tolerance, I would still end up with a 0 point of plus or minus 0.06 degrees. And so after that calibration, I can set the 0 angle and sweep over 0.5 meter, and the laser stays fixed on this Allen key target that I have. And so plus or minus 1 millimeter over half a meter corresponds to a plus or minus 0.1 degree, which was my goal. After calibration, I set up another multi-piece test cut, this time with 4 pieces that actually look like a regular puzzle. So here you can see the cut planner outputs some visualization of what it's going to cut and how it's going to cut. And in this case, each cut is its own group. So it does a retraction after each one, which is not strictly necessary in this case, but simplifies the programming. And so here you can see it's cutting, even though it looks like the saw blade is moving in slow motion because of aliasing with the frame rate. This is actually at 5x speed. And I don't have the top foot mounted right now. I don't know why, but I was just pressing down with my hand and later with the metal bar. And I got a little bit confused, so I took the piece out before it tracted, but this movable table makes life a whole lot easier. And now it's cutting the second piece, which I'll admit that even after I calibrated this, I still don't have a way to rehome the machine without recalibrating. So I have to leave the machine at the U0 point every time. But when I was tightening the blade for this, I actually bumped it off that set point. So I need to redo the calibration and add a homing switch, because I ended up with a similar position error to the last time, but the saving part of the latest G-code generator is that it cuts part of its movement moves as if they were piece moves. So this is like having a lead in and lead out to every cut it does. So this actually let it connect the pieces that wouldn't have connected before. So here's a close-up of those 4 pieces, which came out pretty nice. And when you put them together, you can see that the edges don't line up perfectly because of that positioning error. And the point in the middle should have been exactly 1 point and not that funky bow tie shape. But those 90-degree corners cut really well, and this is looking good so far.